Very good morning to you all. Good morning. So we are still dealing with situations of projectiles, morning. And for example, they can give you a question like this one. A particle is projected from a point with a speed 20 meters per second at an angle of 60 degrees to the horizontal. I'll ask you to express in vector form the velocity v and its displacement r from O at any time. So if you look at such a question, you can have the projectile projected in this way. It's given an initial velocity of 20. Then it has been projected. Now they want us to find the angle of projection is 60. So vertically, is represented by a symbol J in vector form. Then horizontally, it's represented by a symbol I in vector form. So from Vy, the velocity in the vertical, which is equal to U in the vertical plus 80, V in the Y is going to be equal to 20 sine of 60 minus gt, which is the same as 10 root of 3 minus 9.8t. Then horizontally, so this is vertical component of velocity. But as the horizontal component of velocity, which is horizontally, velocity Vx is always equal to Ux plus acceleration in the horizontal times time. So Vx would be U cos of theta plus 0. So Vx is actually 20 cosine of 60, which gives us 10 meters per second. Now, in vector form, the velocity at any time is defined by the component of velocity in the horizontal times I plus the component of velocity in the vertical times j. This is what shows that it is in vector form. Therefore, we shall have the velocity v at any time. Sometimes people write subscript t to mean at any time, is going to be given by 10I plus 10 root 3 minus 9.8t, but the whole of this bracket is for j. So when you go to understanding mechanics and you learn in such projectiles, this is how we're supposed to interpret them. So finally, one can also write the velocity in this form. In column form, it is 10 and 10 root 3 minus 9.8t. So sometimes it will be written without I and j. When it is written in terms of I and j, it is written like this, where I represents the horizontal component, j represents the vertical component. Even here, if you write it like this means that the first one is the horizontal component, and the second one is the vertical component. Now, secondly, they have also said express also its displacement R. Now, vertically, what is the displacement? Y is always ut sine of theta minus gt squared over 2 is the equation for the vertical displacement. So y will be 20 times t times sine of 60 minus 4.9 t squared. So y is actually 10 root 3 t minus 4.9 t squared. It is from here that we have got the vertical displacement. Then we can also get the horizontal displacement. Because in vector form, you have to have both vertical and horizontal. So horizontally, the horizontal displacement x is equal to ut cosine of theta, which is going to be x is equal to 20 times t times cos of 60. And this is going to be x, which is equal to 10t. But r, the vector of displacement, is now going to be defined by xi plus yj. In the column form, it is xy. So the one in the horizontal starts followed by the one in the vertical. So the displacement r will become, our x is 10t I plus 10 root 3 t minus 4.9 t squared. Close brackets j. If you want to write it in column form, r at any time t can be written as 10t and 10 root 3 t minus 4.9 t squared. Then whatever you want from the question can be interpreted using those ideas. So sometimes the number is given when it is in vector form. So it is you to extract out what has been given and go ahead and investigate what the question wants. Unless if someone has a question, what I've discussed so far. Does anyone know the page of understanding mechanics? Where we had projectiles, I wanted to look at one which has been set in terms of vectors. Projectiles. They're on page 277. Okay, let me search for them here. So allow me screen share and I take you to understanding mechanics. Here we are. Hope you don't just look at those books and don't try out the numbers. You don't try out the numbers, you will meet the numbers in the exam. Then you will see fireworks without the fireworks gun. P. I'm expecting some numbers of vectors here, but I can't see. Okay, here they are. Now you can see like these numbers. It's question 13 there. Let me take a look at question 13, then you investigate the rest. Question 13 says, someone read for me question 13. Shakira, read for me question 13. It's right here.
A particle is projected from an origin O at a velocity of 41 plus 11j meters per second and passes through
velocity
a
of
point
4i, that is 4i.
4i plus 11j meters per second and passes through a point P which has a position vector 8i plus xj meters, taking d being 10 meters per second. Find the time taken for the particle to reach P from O and the value of x.
Very good. Now, they have given you the initial velocity. They have given you the initial velocity. We have seen in our earlier discussion that velocity at any one time is given by the initial component of velocity in the horizontal plus the component of velocity in the vertical at any time t. Now, according to this one, the velocity at any time t for the vertical is going to be u sine of theta minus gt. But this one is always the original, which original corresponds to 11. In the vertical, this is because this is the initial velocity. So in the vertical, initially you have 11 minus 9.8 t. Then for the horizontal Vx, because this is u in x, I plus u in the vertical, j. That's why I've considered this to be u in the vertical. So v in the x is the same as u of x, which is equal to 4. Therefore, the velocity at any time is given by 4i plus 11 minus 9.8 t j. But having seen that, they have said find the time taken for the particle to reach P. It passes through P, which P has a position vector that. Now, if this is the position vector, if I may take you back, we have seen that the position vector depends on the position horizontally plus the position what? Vertically. So do you see that horizontally, x is going to be what? 8. And this 8 is got from ut cos of theta, whereby 8 is going to be u cos of theta times t. This u cos theta is the initial velocity with which it is projected horizontally, because u cos theta or ux is always u cosine of theta. Now, according to what we have been given, the initial velocity in the horizontal is 4. So I would say 8 is equal to 4t. Then the time it takes to reach that point is actually 2 seconds. So we have found the time. We are using vectors. Then they are also asking us to find x. X is the vertical displacement. Yeah? The vertical displacement, remember, is got from what expression? Ut sine of theta minus gt squared over 2. But ut sine theta is the vertical component of the initial velocity. The vertical component of initial velocity was 11. So we shall have x is equal to 11 times time t minus 4.9 t squared. The x we are looking for will be, when you substitute the 2 for t, you'll get 22 minus 19.6 22 minus 19.6 will give us 2.4 as the answer. So in most cases, these numbers which concern vectors and projectiles, they're asking you to work backwards. They're asking you to extract information from what has been given, and in one way or the other, you can be in position to follow and get the solution of the question. Let me look at also number 19 so that I close the vectors off. If I look at number 19, number 19 talks about 10 seconds after its projection from the origin, a particle has a position of that. I want to rub off that, first screenshot that. Someone has a question. So which book is that? Understanding Mechanics, page 277. You have it in soft copy. I remember sending it to all of you. Okay, so I can rub and go for number 19. Those who don't have the book, you can screenshot numbers here to try out. Number 19 says 10 seconds after, so time is 10. After projection from the origin, a particle has a position. So the position is defined by 150 I and 200 J meters. Find in vector form the velocity of the projection. They're asking you for the initial velocity, which is u in x, I, plus u in y, j. Now remember one thing. This r can be got from x, I, plus y, j, which is ut cos theta, I, plus ut sine theta, minus gt squared over 2j. So when you sit them in this position, yes, please. Okay. I was saying, if you have this as your R, then R is defined horizontally along I by X, is defined vertically along J by Y. But the equation for X horizontally is ut cos theta. The equation for vertically is that. But according to what has been given, they are telling us horizontally is 150 I minus vertical, which is 200 J. In this case, when you get the particle as a negative, it means the particle is coming up down. So therefore, you extract out and say ut cos of theta is equal to 150. Then you can also extract out and say ut sine of theta minus gt squared over 2 is equal to a negative 200. Okay, then we simplify. Now, if this t, if this t can be made the subject, they have said find in vector form velocity of projection. And 8 after 10 seconds. So if it is 10 seconds, we have seen u cos of theta times the time, which is 10, is going to give us 150. You lose the 10, so u cos of theta is 15. But remember, I told you the horizontal component of velocity is always u cos theta. B plus I, this one will be u sine of theta, j. So I have found the horizontal. The vertical, substitute the 10 in this second one. You'll get 10 of u sine of theta minus 4.9 times 100 is equal to negative 200. So u sine of theta is actually going to be equal to, this is 490 minus 200, you get 290 divided by 10. So u sine theta is 29. So in general, the u horizontally when time is 0, I've said is ux I plus uy j. So u in the horizontal in any time in the beginning now become 15 I plus 29 j. This will become the solution of what you're looking for. So it's all about knowing what the I and the j stand for, then express all the equations we have. The ones which are horizontally go to where I is. The ones which are vertical go to where j is. So if it is velocity, ux is on I, uy is on j. If it is final velocity at any time, vx is on I, vy is on j. If it is displacement, then x is on the I and y is on the j. So that is the special case about these equations. Now, I remember mentioning that also this week I will have to introduce simultaneous projection. So screenshot that, and then we go for simultaneous projection, whereby simultaneous projection occurs once we project items at the same time. Okay. We are discussing now simultaneous projection. Then next week we shall introduce proofs. So people can screenshot that. And then please, if you see these numbers, where we have projectiles on an inclined plane, please run away. You have survived, they are not at your level. They are removed from your syllabus. So when you see a projectile projected on an inclined plane, run. Otherwise, your life will become hell. Let me use another book. Okay. But there are some numbers I had asked you take a look at in this regard, whereby we are supposed to visit numbers, but according to how people solve numbers, they're not very good at them. So you find that even if I send a post, people sometimes just don't mind so much about going for those numbers. Now, I sent a number last time. I screenshotted for you examples from Postal, which we are showing simultaneous projection. But we need to have the following notes as I'm going to identify them. One, when a particle is projected simultaneously with another one, and they all live at the same time, then those particles take the same time of travel. And if they take the same times of travel, then when they collide, First of all, their heights are the same. When they collide, their heights are the what? Are the same. If their heights are the same, these are some of the items we are going to see. So we are introducing simultaneous projection. And I've said when particles are projected simultaneously, then the time of travel is the same. That is 1. 2, collisions occur at the same height. Same height, it means y1 is equal to y2. Okay? If they leave the same position, they are projected from the same position, not from opposite position, but from the same position. You're projecting them from the doorway, both of them, maybe one after the other, and they collide, then height is the same, and horizontal displacement is the same. For a collision to occur. What does that mean? This is what it means. For example, when you project a particle from here with initial speed u1, and this particle goes and it collides with another particle which has been projected with a speed u2. When these two particles collide, here where they are colliding, at this height, you will see that both of them, this one has a height maybe y1, this one has a height maybe y2, but both of those heights are equal. So they are at the same height. Whereas this one could have moved the distance x1, this projection was maybe θ1, this one's projection was maybe θ2. Then this one could have moved the displacement maybe x2. But when they are up here on collision, both heights are what? Are the same. That is situation 1. Then the second situation is what I've talked about. When we project them from the same point, the initial speed u1, and then you project another one with initial speed u2, project this one with θ1, project this one with θ2. And then these particles, as they are moving, they end up doing what? Colliding. Here where they are colliding, they are going to collide one at the same height. Y is the same. Then also horizontally, they would have traveled the same what? Same distance. So this occurs when you have been projecting them at the same position, but the times of travel may be different. This one could have been traveling maybe at a time t, then maybe this one, which was projected later, has taken a time of t minus n, t minus some seconds. Okay, so we have to put those considerations into practice. So with that knowledge, let's look at an example of what I had sent earlier. I want to screen share another one. Screen share new where you are here. So look at this question. I remember sending it to you guys to try to look at it. A particle P, someone should read. Teacher shouldn't read when he's also teaching. Monica, read for us the question.
A particle P is projected from point O with an initial velocity of 60 meters per second at an angle of 30 degrees to the horizontal. At the same instant, a second particle Q is projected in the opposite direction with an initial speed of 50 meters per second from a point level with O and 100 meters from O. If the particles collide, find the angle of projection of Q and find when the collision occurs.
So they're asking us for the time when the collision occurs. They're asking us for the angle of projection of Q. Can people take that screenshot of the question and I go and use the other page, white page? Okay, hope you have already got it. You're going to tell me what I want from there. So if you come back to this page, this is example 2, example 3. And we have seen that in example 3, there are two particles projected. One is projected at an angle of what? 60. Another one is being projected at an angle of theta. These particles collide. Where they are colliding, this one will have traveled x1, this one will have traveled x2. The distance between the two particles is 100 meters. They want us to find the time of collision. What is the initial speed of? This is P, this is Q. What is the initial speed of P? The initial speed of P is 60. The initial speed of Q is 50. So this is 60 meters per second. This is 50 meters per second. Now, like I mentioned, here height 1 is equal to height what? Height 2. So if I investigate height 1, it's going to be equal to U1 sine theta 1 minus GT squared over 2. There is a T here. They take the same time because it was simultaneous projection, same instant. Y1 would be 60 Y1 would be 60 times time times sine of 60 minus 9.8 T squared divided by 2. The reason I've been writing 4.9 is because 9.8 divided by 2, you get 4.9. So this will give me 30 root 3, because sine 60 is root 3 over 2 times T minus 4.9 T squared is our Y1. This gives me equation 1. When you go to Y2, Y2 will be U2 times T sine theta 2 minus GT squared over 2. You get Y2 as 50 T times theta sine theta minus 4.9 T squared. When you equate Y1 and Y2, you realize you have 50 T sine of theta minus 4.9 T squared is equal to 30 root 3 T minus 4.9 T squared. Then when you subtract the 4.9 T squared off, you remain with 50 T sine of theta is equal to 30 root of 3 T. I can also vamoosh this T. Then this 10 with this one, then sine of theta is equal to 3 root 3 divided by 5. When you press the calculator, what answer do we get? Answer? Does it fit where it's greater? Does it give you math error? Someone please give me an answer. Gives us math error. Where could the problem have been? This was 60. 60 root 3, 60 root 3 over 2, you get 30 root 3. The other one was 50. Why are we not having the answer we expect? Let's try out the other option. The other option is use the horizontal displacement. This one is giving us an impossibility. But it should have given us something. 50t sine of theta. Okay. Here in the displacement horizontally, let me first pause this. When you look at x1, x1 gives you 60 times t cos of 60, which will give us 30t. Then x2 will give us 50t cosine of theta is equal to 50t cos of theta. But when you add the two, x1 plus x2, both of them should give us 100. So it means 30t plus 50t cos of theta is 100. It is also from here that we can see that 30 plus 50 cos theta, these two combined give you 100 over t. According to what we are given, I think I've not. Wait, this was not 60, it was 30. Let me first go back and check. Guys, this question was saying this was 60 meters per second and the angle was 30. Sorry. So we need to change that. So this is 30. then it is possible. This is 30, this is going to be sine of 30. Sine of 30 gives us a half, which a half times 60 is 30. So if it is 30, there is no root 3. If there is no root 3, then we shall have only the following. So this is 30t. This is 30t. The t can be lost. So this will give us 3 or 30 out of 50. So sine theta can be attained. If you attain sine theta, then sine theta is 3 out of 5. Then this will be 4, a cos. So if I substitute for cos theta right here, of course, you can now get the angle of projection. Eh? What is that angle? Theta is sine inverse of 3 over 5, which is 50 what? Someone get us that answer.
That is 6.87.
That is 6.57.
87.
So you substitute it here, the cosine, which is 4 over 5, you do the algebra, it gives you time as 10 over 7. And that is our answer. So if I may show you, that's the solution, I think. Let's check it out. Yes, the angle was 3 over 5. The time is, you say 36.87,
87.
which is 36.9. Then the time, 10 divided by 7, what do you get? Ten divided by 7, do you get 1.09?
One point 42.
1.4, let me check, what have I done? We have got the 30t. Oh, I did not change this one. This was supposed to be cos of 30, which gives us 30 root 3 t. So it changes the solution here. So this is 30 root 3 t plus 50 times t times cos, which is 4 over 5, is 100. So this gives us 40. So 40 plus 30 root 3 times t is 100. When you make t the subject, what answer do you get? Someone can answer?
1.087.
1.09, eh? Which is the correct answer. So if we go back to the other screen, You see, you can take this screenshot, but you also have Boston, page 277. You see their vector numbers also here. I wanted to look for one other number which requires projection. Yeah, there's number 16 here. There are two numbers. There is 16, there is number 17. Which one should I try out? Definitely the other one will be yours. So 16 and 17, which number should I try out?
Seventeen.
17, eh? Okay. Let me take a screenshot here so that I can read it from this side. So we go back to our white page. So the number 17, you say the answer is 1.09 seconds. So we have a new question. That question is number 17. And Jose, can you read for us number 17? Yes, are you there? Okay, Mercy, read for us the question. Yeah. Where are the people I'm calling? Maria, can you read for us the question? Okay, Mercy, read. Mercy, okay, read it from
A
here.
and B are 2 points on level ground, 60 meters apart. A particle is projected from A towards B with the initial velocity 30 meters per second at 45 degrees to the horizontal. At the same instant, a particle is projected from B towards A with the same initial velocity. Find when the particles collide and the height above the level AB at which they collide.
So the particles have been projected. The particles are a distance of 60 meters apart initially. One particle has been projected from A with an initial speed of 30 at an angle 45 to the horizontal. At the same instant, a particle is projected from B towards A with the same initial velocity. Same initial velocity, but they have not told you that it's the same angle. Find when the particles collide and the height above the level AB at which they collide. So they are colliding at a height Y, which is the same distance x1 away, x2 away. To start with, like we said, what we have seen earlier, the heights are the same. So y1 is equal to 30 times the time times sine of 45 minus 4.9 t squared. Then the second one, it is 30 times the same time times sine of theta minus 4.9 t squared. But because these two heights are the same, it means 30 t sine of 45 is going to be equal to 30 t sine of theta. With this, when you lose the time, you will get sine theta is equal to sine 45. So it means also theta is 45. So if theta is 45, x1 is going to be 30 times t times cos 45. X2 is going to be 30 times t times sine 45, cos 45. These two are the same, they sum up to 60. So if these two sum up to 60, we shall get 30 over root 2 t plus 30 over root 2 t is equal to 60. When I add the 30 and 30, I get 60. So I'll get 60 over root 2 t is equal to 60. When I lose the root 60, my time is root 2 seconds. The time is root 2 seconds. Substitute in n of the equations and find the vertical displacement where they collide. So y is equal to 30 times root 2 times 1 over root 2 sine of 30 minus 4.9 times 1 over 2. Because when you square a times root times 2, when you square root 2, you get 2. So the root 2 here can vanish. We shall have y is equal to 30 minus 9.8. When you subtract off 9.8 from 30, the answer is 20.2 meters. So they have met at a height of 20.2 meters. Any question on that one? They said find when they collide and height above the level AB where they have collided. We have found them. So ideally, simultaneous projection is all about one, knowing that they are colliding at the same height, if their level of projection was the same. Two, if you know the distance between them, then x1 plus x2 is the same. Yeah? Do you have questions? Any questions? So we're going to start with that number 16 and proceed and do other numbers. But before I can go, I am yet to introduce proofs. Allow me to start with this one today, just for the sake of simultaneous projection. Allow me to take a look at number. There are these three numbers. They are all simultaneous projection. They are very interesting. Let me look at number 18 today. The next lesson, I will start with number 19 as my first proof. Then we shall proceed with other proofs. So do we see number 18, all of us? Let us go through it just to finish our minutes because we are left with around 11 minutes. Let me take the screenshot. But don't hesitate to try out the other two. Try out the other two also so that you know that you are a serious mathematician. When you get challenges, inbox me, I see how I can guide you. But it's good to come when we have at least tried out something. Now, I go back to our white page. If I can go, Cynthia, read for us number 18.
Two particles P and Q are fired simultaneously from 2 points A and B on level ground with speeds of projection U and U2 respectively. P is projected so as to achieve its maximum range, which is AB. If the particles collide, find the angle of projection of Q. Find also in terms of U and G the height at which the particles collide.
Okay, I think you can see that these questions are almost similar, which they ask concerning these items of collisions. Ideally, the questions sound to be the same. Now, we are having a level where we are projecting two items, one with a speed u, the other one with a speed 2u. This one is projected so as to attain its maximum range. And you should know that when a particle is projected to attain maximum range, what is the angle of projection? Monica, when the particle is projected to attain maximum range, what should be the angle of projection?
45.
Yeah?
I think 45.
45, lovely, thank you. So this would have been its range. Maximum, eh? So we know its angle of projection, we know its initial velocity, they are colliding at a height y. We don't know this one's angle of projection. Remember we said when they collide, the first height for the first one is ut sine of 45 minus gt squared over 2. The second one, y2, is 2u t sine of theta minus gt squared over 2. When you equate the two, you'll get ut sine 45 minus 4.9 t squared is equal to 2ut sine theta minus 4.9 t squared. When you lose those two items, I can also lose this t. I can also lose this u with this one. Finally, sine of theta is going to be equal to a half sine of 45. So sine of theta is actually going to be equal to sine 45 is 1 over root 2. So this is 1 over 2 root 2. When you get the inverse, what answer is this? Where is Swale? Swale, give us the answer. Swale, give us the answer. These boys today are not serious. Girls, give me the answer.
$45.
45. Are you sure? It is not 45. 45 is 1 over root 2.
20.7.
Eh?
20.7.
20.7 degrees. You see, the boys today don't know which side you woke up from. Press the calculator, mister. That was who, Jesse. Okay. They also asked for the height. They asked for, what did they ask for? They asked us to find the angle of projection of Q in terms of, find also in terms of U and G, the height at which the particles will collide. So where they are colliding in terms of U and G. You know, for time to get maximum range, the range is equal to what? Maximum range is U out of G squared. So if that is the case, they're asking for the height. And the height requires us to get the time, which time we don't know yet. From X is equal to UT, cos of theta, X1 is equal to U times T times 1 over root 2. So X1 is equal to UT over root 2. Then X2 is going to be equal to this. X2 will be 2U times T times cos of theta. Now, because we saw sine theta is that, extract out a right angle triangle. That's why trig is relevant here. So this is 1, this is 2 root 2. 2 root 2 squared, you get 4 times 2, which is 8. 8 minus 1, you get 9, 7. So this is root of 7. So we shall have theta is equal to X2 will be 2U times T times root of 7 out of 2 root of 2. And lose this 2, then X2 can be UT root of 7 divided by root 2. But UT over root 2 is X1. So it means X2 is actually equal to X1 root of 7, which is another very important vital equation. Now, that is the case. They want us to get the height in terms of U and G. In terms of U and G, we can have, how can we eliminate the time? Because we are looking for y can be got from x tan. I can wrap this side. Remember the equation of the trajectory? Y is equal to x tan theta minus x squared, gx squared over 2u squared. Y is equal to x tan theta minus gx squared over 2u squared into 1 plus tan squared of theta. I can show you that y1 is equal to x1 times tan of 45, which is 1, minus g of x1 squared over 2u squared into 1 plus tan squared of theta, which is tan squared of 45. This is 1, this is 2, so these 2 can be lost with this one. So y1 can be x1 minus gx1 squared over u squared. Then for y2, tan of theta is 1 over root 7. So y2 will be equal to x2 times 1 over root 7 minus g of x2 squared divided by 2 times 4 u squared into 1 plus 1 out of 7. So for u2, it will be x2 out of 7, root of 7, minus g of x squared out of 8u squared into 8 out of 7. I can lose the 8, then this will give me x2 over root 2 minus gx squared over 7u squared. But because these 2 items are the same, we can equate them. Then have x1 minus gx1 squared over u squared is equal to x2 out of root 2 minus gx2 squared out of 7u squared. But remember, x2 is x1 root 7. So we shall have x1 minus g of x1 squared over u squared is equal to x1 root of 7 divided by root of 2 minus g of x1 squared 7 divided by 7u squared. I lose the 7, the whole of this part becomes the same as this part. What the hell is this? It's giving us x1. X1 is what? The x1 is cancelling out. I thought I would use this to find x1, because if I get x1, it would be easier for me to find time. Then I make t the subject and I drop it up there. But it looks like it's vanishing. What do you think? Our time is even up. We got the angle, we are left with finding the particle displacement. They never said in terms of t. Let me check once again. Find also in terms of u and t the height at which the particles collide. So time is not there, so we have to find an expression for time. Even x is not known. That is why I was trying to use that equation to find the x. Wait, let me see. Since time is up, let me first leave it at this. Take a look at it and see how you can investigate it. I'm going to go over it, then I will post the solution. But in case someone comes up with the answer, someone should check Bostock. This exercise, see which answers they have. This was exercise. Page 286, this was exercise 9C. Should check on the answers they have. Let me check them out here. Exercise 9C. Hey, who gave back? Babysitting? Yeah, right. Sorry. Now you have to take care of the baby. Okay. That's how we're almost done. Yeah, I don't see other answers. We should check in the other one I sent. But in case of anything, when I'm done with my senior 6 class, I'm going to take a look at the number and try it out separately. Then I'll post what I'll have got. Okay, we can stop there for today. So next week we are coming in for proofs. So you see how proofs can be interesting. This is just an open for how proofs can look like. The baby is also knowing the time is now.